Okay. Should be up, I think. Yep, looks good. So welcome back. Last time I made a bit of a breakthrough with the hypervisor, and I fixed the guarded execution issue, and I actually just committed all of that. I think the tree is clean now. Yeah. Hey, Flame Eyes. So, yeah, today I want to get rid of these. I'm going to support SIMD load. So I did some work after the stream last time. I implemented, if you look at the log, I already committed everything. But basically, these. This is what you didn't see. I added support for integer paired loads and stores, which was missing, and I fixed a bug here. I had an issue with sign extension not truncating to 32 bits properly when the instruction writes in 32-bit mode. So I added these, which are the unscaled offset loads and the paired load and also the paired store, because I saw accesses for those and I didn't feel like just bypassing everything. And then this is just to support, since I need to do 128-bit writes now, I just gonna clean this up and because the MIO trace instructions, messages only do 64 bits in the payload. Basically, actually, did that get put on backwards or? Hold on, I feel like I messed up the commit order here. Did I mess that up? 7B8? Oh yeah, I mean, how did that end up happening? That needs to go in the current commit. How do I do this? I think I can cheat. I can revert that and then revert the revert and fix it. Yeah, that'll probably do it. Or not. So, yeah. Exceptions, I don't need that. Yeah. So that reverts, and then I can just do that. Split, not that, yes, that, yes, that, yes, that. Yeah, that'll do it. And then revert that again and rebase on origin, and then I can just put the revert there and then revert it here, and that'll keep the commit. Yeah. So now it makes sense. Yeah. So what I did in that commit was basically, yeah. So because an MIO trace message only has 64 bits for the payload, and I don't want to make it variable length just yet. I could, but it's not worth it. If it's more than 64 bits, I just send 2 messages at incrementing addresses. So, that usually should be cleaned up, but yeah. Where is that? NVM. Yeah, this is old junk. I want a flag for this. Let me add a flag for that. Like a slower flag or something. Actually, it doesn't matter. I don't need this anymore because I think now with the watchdog, even if it hangs in code due to an MMIO write and never flushes the buffers, the watchdog will kick in and then kick the USB. So as long as like the hardware isn't dead, the watchdog will actually flush the trace for me, which is really nice. So let me just clean that up real quick. So quick fix up on that, just to get history a bit cleaner. And now that I'm Have I got this clean again? Let me just run my magic clank format thing. Okay, that's fine. And I'm going to push, and I'm going to merge that PR about the MMIO range decoding because that's useful. Give me a second. Mini. And so let me see if I hope I didn't break that. This one, yeah. This would also be useful, actually. Let me just merge everything right now. So first, the address lookup. I think all that was fixed. It looks like it can be merged. And wait a second. I think the conversation. I think we're fine on that. So let me just do a quick look over of this. Just look up. Yeah, actually, I will probably be refactoring a lot of the the module organization of the Python stuff next. Once I want to start building MMIO tracers, I'll probably move the hypervisor to an actual proper module folder and stuff. Yeah, there's in build address lookup current parser. This is for ADT. Oh, cute! I like that. Dev zone looks it up, just prints it there, builds it there, and then there's this whole thing. Yeah, I'm not gonna bother with the with reviewing this right now because if we have a bug, I'm sure we'll figure it out. So I just test it. I'm not super anal about line by line reviewing of mini code because if something's broken, we'll fix it. It's fine as long as the general approach is reasonable. Then I'm good. So I'm just going to merge this. And then the checksumming stuff, where did this end up? Yeah, yep. So let's see how that looks like. Got a feature. Yeah, this is the same thing I did before. Data incentive. Cool, I got implemented. Data checksum. Yep. Data checksum features. Get all the NOP will, I think, always send, all the features. And then this side will write the sentinel. Oh, this needs a little change, but I can do it afterwards. Basically, oh no, this is fine, right? The Python side is fine. And checksums, it will read 4 more bytes, and then that's in the union, as I asked. And the reply is the same thing, and I got that. That all looks good. Checksum finder, data and checksum, yep. And features, if it's UR, don't kill that, yep. And then the checksum val, yeah. And then finally, I would have read sentinel, and that's fine. And for the writes, does a queue, and does a queue, and then flush. Yeah, that works. Yep, no issues there. Yeah, this all looks good to me. Okay. So that can be merged too, and just merge it straight. It has I needed to approve the just review it. And what's this doing? Oh, didn't run the checks yet, so let's do that. Cool, no problem. All right, let's see if that works. And that's a good point to do this because I'm clean. So let's fetch that. Yeah. All good. And okay, let's see where we are right now. I wanted to check how these things. So I'll fix those later. So right now I think this fails on like one of the on one of the loads or something. But instead of bypassing it, I want to fix this now. That was the compression, I think. Yeah, it's hopefully a bit faster now without the checksums. Cool, and we get, now it shows us the MMIO regions, which is very nice. Ooh, what happened there? What just happened there? That was interesting. That shouldn't happen. That looks like something broke with the checksums. That is weird. That is quite interesting. Handle event. So it got an event structure, and then it got a 0 event. How does that happen? Let me just run it again. Ooh. Wait. How does that happen? Something very weird happened. Event overflow? Well, that is weird. Something very strange happened here. I think we have a bug in the stuff I just merged. Okay, no, that's probably fine. It probably just messed up because of the thing failing in the middle of the USB code. But first of all, why? Yeah, interesting. I feel like we have some kind of No, something is definitely broken there. And it failed in D. And D abort. I think something must be broken in the event support because this was not happening earlier. Let's look at the checksumming thing. So I think it's probably this commit. Nothing really changed there though. How would the MMIO address lookup break it though? It's just by making it slower? That doesn't make sense. This is synchronous. Let's try that without the lookup, but that doesn't make sense. I guess this makes sense for Python to break things. No, it's not that. It's D plus. So this time it got this far, but not this far, which is interesting. That also looks overflowy. So it failed in here? Yeah. Wait, how is that even possible? Oh, that is weird. Hold on. Let me just check out this to make sure I'm not doing anything dumb. Okay, this makes more sense. This is an actual MMIO breaking things. Which is, this is APCIE, that's fine. That's kind of expected. But I don't think that's what I saw earlier, so what just happened? Unless it was close to there? So, let's try that one. Ooh, okay, that is weird. How does adding decode on the Python side cause this? That doesn't make any sense. Well, that's fine, that's the bark, but oh, maybe it's just it changes the timing enough that it maybe just changes the timing enough that it breaks. Okay, let me set the thing to sync again. See if we get anywhere else. Because that doesn't really make any sense for a Python side change to break this side. That is weird. This time it worked, but it got stuck in D. Oh. Okay, that is weird. It wasn't quite in the end. Definitely breaks while sending events or something. Okay, let me add the U delay on that again and see how we do if it's slower. I bet it's just like I have a buffer overflow here or something. It's also possible that like the ring buffer code is messed up, and if the buffer fills up, it breaks, for example. No, I could see that. Hmm. And now I'm getting like events trickling in. Oh yeah, that is weird. Also, that's broken, obviously. That might be it. It might be that the USB code is broken. Well, there's an easy way of testing that. In USB devices 3, this is the buffer size. Let's just set it to 64K. And if it overflows, then really quickly, then we know it's the issue. Or if it works, then there's a different issue. No, it happened. And is it actually broken? Okay. Yeah, it is broken. That's quite annoying. That's the ongoing thing. Fits transfer in progress, start transfer. Why does that happen? That doesn't make a lot of sense. It's 10.5. 10.5 is what? Bulk in. So the one transmitting, yeah. And that gets called where? Here. Data tier restarts the phase. Handle transfer done. Okay, first of all, let's send those out to the UART. And it's probably because it's stuck in a read, right? No, write, sorry. Because it goes to the host, yeah. Bulk in, so it calls bulk in transfer, yeah, and it means start transfer, yeah. So it's probably stuck here. Wait, hold on. Yeah, if it's in progress, then returns. So that means it like overlapped the other code? Hmm. It runs on the same core until the panic. But I'm trying to use the fact that the transfer was ongoing when the panic code run to guess what happened. Because that kind of means it died in the middle of the USB code. I mean, it's not thread safe, but the panic code should only run if the main code died. And if the main code died in the WC3 code, that's kind of interesting. Oh, wait, I know what happens. I know what's going on. Of course. It's probably just... Yeah, no. Okay. I know what's going on. It's probably just dumb. It's just the watchdog is just barking because MIO trace is taking too long. That would make sense. So yeah, no, obviously, I need to stop the watchdog around MMIO trace calls, because otherwise, if the buffer fills up, then it might actually block for more than a second. So yeah, of course. So here in HDVM, in your proxy send event, here basically I need a HVPY. Yeah. That's probably just what it is. But of course, Python is always going to process events, fast enough that an individual event is not going to block for more than 1 second. But because there's buffering involved, then yeah, sure. Or not. Interesting. Now it died in D, at the beginning of D. Exception. Does D abort, and then that's it. And then it... This can't possibly take more than 1 second. Okay, let's add more breadcrumbs to this. Maybe it is killing my USB somehow. This PMP stuff is a little bit suspicious. Let's just have some breadcrumbs here. It might actually be an MMIO killing me thing, to be honest. Interesting, that actually died. Wait, hold on, what? Hold on, what? How'd I get this again? It didn't actually restart because it didn't show it here. Where'd this come from? What? It's like the ring buffer, the beginning of the ring buffer or something. It's replaying the buffer. But wait, but there should be... No, in this way it wouldn't, right? So anyway, R347. 347. So yeah, it died and emit MMIO trace, as one might expect. Well, that is weird. Okay, so one thing I'm gonna do is in the watchdog timer, if it barks, I'm gonna delay for 10 seconds to give it time to do stuff, and then reprint the breadcrumbs. See if it's advanced or did anything. So we know if it's still running. But the interesting thing is it barked here. And I'm already suspending around here. Oh, IODEV flash, crap, I'm dumb. Yeah, no, sorry, I'm stupid. If it's sync mode, then it definitely needs to resume there. Sorry, I'm just stupid. It barked, and now it's gonna be like, it's fine. But why is it so slow, though? Oh, that is weird. Ooh, okay, that's interesting. So, yes and no. Oh, is there something in the Python? Is there a... Oh, is there a pathological case in the Python that causes it to be really slow in those lookups? Betcha that's what it is. Yeah, I feel like something is something in the Python. Oh yeah. Look at that. Look at that. Those PMP26 lookups take forever. And now it's not crashing because now I made the watchdog not... Ooh, yeah, okay. What happened there? Control C is... Yeah, that doesn't work. That's annoying, isn't it? Yeah, okay, that makes sense. Okay, so first... let me add those... Where am I? Git stash, git checkout, mass main, git stash, apply, diff. Okay, so first, let's add not that. Actually, I need to split that. Don't split. Yes, edit, not the delay. That should be enough. to suspend. So that fixes that. And then the breadcrumbs are probably useful anyways, so let's put those in there. You can probably just define that to nothing later anyway if I don't need it. And I don't need that. Do not sync that. Well, actually, yes and no. We'll do it now, but not that. Yes. And I don't think we need that anymore. So, yes. Yes, so obviously there's something really dumb here. So we know which ones take forever. These things. So if I just run that, and then cancel it halfway through, actually, I probably don't even need that. I probably just, because it's just the ADT debug thing, but I'll just do it like this. ADT dot where was that? Did I not merge that properly? Oh yeah, I need to. Sorry. Get rid of that. Apply, and then I can just go back to that. Then for address lookup, this thing. L dot lookup. No, that's fast. That is actually fast. Oh, it's a lookup all. No, that's still fine. Oh, hold on. This is using the hypervisor ADT. No, but it's before we touch anything. That is interesting. Okay, let's try it like that. The write or the flush will be blocking. Both could block. The write could block if the buffer is full. The flush will block until the packets get sent to the host. So it'll block until the last packet, basically. What just happened here? Tiffany spends time on the lookup more than anything else. Yeah, look at that. What just happened there? And like, yeah, these 0 ones are taking forever. It did work though. But like, of course, now that Control C is going to take forever until ooh. But why? It works fine when I just run it from the console. What's the name of that thing? That's instant. What sense does that make? There's no way the parse is there. No, it isn't. Was it not the lookup? It looks like it wasn't the lookup. No, it is the lookup, yeah. Oh, that is weird, and only sometimes, right? What is it, though? Yeah, it's the lookup function, all right. Yeah. But why? I'm so confused. Oh, I think I know what's going on. I know what's going on. I know what's going on. This is going to be some wrapper type. And range is going to be optimized so that for integers, it knows how to... Yeah. I bet... Look. Or not. Oh, yeah, no, it's the hex adapter. It's my hex adapter breaking things. I bet. Nah. Yeah, see that? Yeah, they're hex actually. And now, if I do this... then it takes forever because it actually iterates through the whole range. Haha! That'll fix it. I'm quite confident about that. Let's reboot that. Actually, I should probably just do that in the lookup function. That looks much faster, doesn't it? There we go. And it fails where I expect it to fail. Those are some fun bugs. Okay, kill that. And commit that. Okay, so this is what I actually wanted to implement today. We took care of the stupidity. So, yeah, these SIMD loads. I want to make like a dispatcher. And I don't know if I want to do it by just loading and storing all SIMD state, or if I want to have dispatcher for individual register reads writes. But I think since these are so rare, probably just doing the whole state is fine for now, because eventually I'm going to want something to load this from Python, and I can make it a lazy thing so that, you know, when you first access the array, it'll do the load, and you wouldn't want to do it for every register. So I think I'm just going to do it like that. So basically this. And it should basically be 32 registers. So I think I can just put it here, an exception ASM, because it's kind of related. Or maybe util. Is there utils ASM? Yeah, there is. And utils ASM, it'll be fine. Yeah, this makes sense. So basically, what do they call these? Just SIMD and FP, yeah. They don't even call it Neon anymore, do they? Just SIMD. This Q, isn't it? Yeah. Let's see. Oh, is there a double thing for these? I don't think so. No. Oh, there's vector things. Oh, this might work. Yeah. ST4, is that what it is? Oh, this is with interleaving. That's not what I want to do, though. Oh, there's a pair. Okay. They do have pairs. I think this is the one I want. Where's that? This is, yeah. LDP. It's just SDP. Okay, okay, yeah, that's what I thought. Yeah, that makes sense. So let's do that again. That makes sense. And we'll just do it like this. And then in utils.h, it's not even U64, so and let's just put this in the proxy because it's going to be useful. Yeah, I think it's like it's kind of here, but not really here. Yeah. Not really like the mess of things we have here, but also, why is that out of order? Why is this vector not in the right order here? Is it self-malloc or self-umalloc? It's umalloc, right? Uh, Self-heap malloc, yeah. Actually, I'm going to do it in utils so that I get better there. And I can probably just do a little lazy thing here and make it nice. I just need to do a flush SIMD state thing. Why is the kernel using SIMD instructions? Because it is. I don't know. It's not Linux. It's not banned. I mean, it's not really banned in Linux either if you're in specific places anyway. So these are called. Let me just actually look up. Okay, so these are just like the key things, and then the vectors are well. And actually, for the shell, I want to push SIMD registers on every operation. Yeah. I think that works. And the right way I want to do this is if I assign to V, I want the assignments. This will make a little adapter thing here. I don't need the object anymore. This is, I don't even know why I have this anymore. This is Python 3. I don't need that. Self. So yeah, this is just just like that. And that item was not yet supported, and then basically just push SIMD. Actually, I'll just do it like no, I know how I'm going to do this. I don't need that. I'm just going to do it like if SIMD is not none, then it'll be like data equals type. Instead of SIMD type dot build SIMD, like that. Yeah, and then in get SIMD, it just gets the data and type. Then SIMD type, and basically yeah, that makes sense. And then SIMD is none, then get SIMD state, yeah. Just do it like that. What is this? Read mem sim debuff. What am I doing here? Build. So the white mem is there. Yeah. Read mem. Doesn't make any sense. It's just a length. I think that'll work. And then it'll just be self.get SIMD And I need a type for that, which is going to be not structure, basically. And we don't have 128-bit registers, but I did do this in Proxy here. There was a thing. I think. Oh, did I not commit that? I think I wasn't doing that. It was just, oh yeah, I forgot. I was using erase for that. Yeah, I looked that up and then I didn't use it at the end. There's a thing in construct for this. Not that, but bytes. Yeah, that's what it was. Yes. And I'm kind of going to overload this probably eventually. What I'm going to do is, these are single element registers, but I'm going to kind of overload the meaning of this and just do it as give me arrays on everything. So they're called BHSDQ. HS D and Q. And then since these are basically, let me just do an identity check there. BHSDQ, is that what it was? Yeah. Let's see if that works. Reboot, chain load that. I didn't really need to do this, but, you know, sounded like a good idea. Sorry, int 8ul. I didn't. Shell. Oh, yeah. BHSDQ. Yeah, V is just for vectors, right? But we don't really know what those are. Depends, I guess, on the instructions. So let's do it like this. That. And if I do u.q0, I get a 0. Q1, if I set it to 1, then I do get that. And if I do something like that's not how it works. It's empty vector element. Is it moff q or I don't know how this stuff works. Floating point move register. Fmov is what it is. Hmm. It sounds dumb, but like, hold on. What's the easy move the entire register thing? uh, just that one? Yeah, no, that should be it. Just fmov, but it only does up to D. How do I do a Q? Really? There's no instruction to just move the whole thing? I mean, whatever. I can do just D, but... And that did not work. um... So is that there? No, that's not there. That did not work at all. That does work. And if I do Q1... Okay, first of all, that's backwards. I got the... Yeah, I need the swap thing on the integer thing, but also my pushing didn't work. So if I do D, that'll work. Yes, 1, 0. But... Okay, so the flushing does work. And if I do X0, D0, that is a 2. We put a 1 there. Pushing doesn't work. Oh, now it did. Hold on. Oh, because this... Yeah, I know what happened. This only gets called on printable things. So that's... Ah. Oh, I didn't realize that. Is there a way of... Yes, if I do this like that... Yeah. It needs to be a value to do that. How do I fix that? Actually, just do console Python is that thing. Not that. Oh, this is new. Compiles, run code, exec. Let's reset buffer. Okay. Basically, run code is what I want to override. Yeah. And so exec is going to do the display hook thing, I guess. Or not. Who does that? Hmm. I mean, obviously that works, but... Hmm. Is there a mode for consoles or something that's going on here? How does that work? Make sure I got the right version. I think it's 3.8, yeah. Hmm. I don't get it. How does this work? Oh, probably just setting it says PS1, I bet. No. Oh, is it? No, not raw input, because that doesn't make sense. I'm confused. How does this even work? This says that doesn't even return anything. Oh, eval? I mean, yeah, that'll do it, but that's not what I want, though. I know this doesn't matter right now, but I'm really annoyed that I don't understand how this possibly works. What am I missing? Oh, is it that? No. I am so confused right now. Is it a thing about doing this inside a regular shell? Not swap. Is it what's that thing? Swapped. What? What? Hmm. Oh, because that's in globals now. Yeah, because it kills that. That's my fault. That's because of this. I probably should just do it like that. Yeah. I'm real confused. It runs a code object. Command compiler. Was that what it is? Is it because of the console thing? I'm real curious now if this is a thing. It doesn't. Does it do that? No. Of course that doesn't work. Thank you, Python. That is interesting. Hmm. What's this? Oh yeah, it's like that. Oh, that works? Yeah. Call file name single. That's what it is. That's interesting. Okay, fine. That is interesting. That is not documented. It's already documented here. Single exec eval. It doesn't even say that. Huh. Interesting. Okay. So anyway, yeah, what I wanted to do here is and it's the same as we were doing this. Not doing monpol here. Actually, monpol should really be somewhere else. And basically that should move here. And it's not really global anymore, though. It would be in the locals for this, which... that doesn't get called with that. Locals... Yeah, it's just locals, okay. So just do... Okay, that should do it. And then finally, I can just do that and 6, and then it is there, yeah. Cool. That does work. So D works, but Q doesn't, I think. No, it does. Yeah, I think it works then. It's just that there wasn't flashing earlier. Okay. So that's that. And this is all basically useless because it doesn't matter for the hypervisor, but I wanted to do it anyway. So it's good for debugging, though. Actually, I could have muted those in Python if I really wanted to, but I'm not going to. So what I actually wanted to do is here an HVVM is... I'm going to take off all of this and let it fire on all of them. And guest... and see what the first one that fails is. And we're just going to implement enough of those. I'll put all of this in. Move that on there, whatever. Yeah, so it's a simple load on this one. And in this case, it would just be probably the load bits of that. So let's do those. Store, load, vector, yeah. Not vector, D0, D1. Okay, so we had this, and it should be FF. Oh, and then the tricky thing is that this isn't a normal load store. No, it is. Yeah, it's fine. So for loads, I need to get the SIMD state. So basically, is it basically a memcopy one? Yeah, 64-bit. Let's see how I want to do this. Okay, so first, this one is just a D load, so it's 64 bits. And it's just going to be the RT. What's option anyway? That's the extend stuff, isn't it? Yeah. Subboard index? That's a scale 1 size. Yeah, that's the reg extend thing. Yeah, that's the offset thing. I don't care about that. So basically just these stop bits. F, F, E. So how do those work? Do those replace the whole thing, or do they... Should be explained here. Actually, I need to double check that. Yeah, it is 0 extent, so then we actually don't care about the width, because the main code is going to do that. What's that? Oh, I see. It's just a... Okay, anyway, whatever. So we're back to here. Actually, I can just test that theory in Python anyway. That didn't work. I know there's stuff here. Yeah. Why did that work now? No. Why did that not work the first time? Oh, probably because it was already dirty or something. No, something is weird. Oh, no, it isn't. Yeah. Yeah, so that's basically, if I do a D, it does erase it. And if I do like a Q and get that, and then I do like a B0, it does, yeah, it does 0 paths. So in that case, basically these size is a standard thing. 1, 10, 11. OPC will always be 0, 1. So in that case, I do want an F there. And this makes the 3FE0, 0, 0, 0, 0 is what I want. So in this case, it'll be 3D, no, 3C. So it's D, and to do D there, that's 3C. What's the D? I'm implementing something that is not what I want to implement. Hold on. Let's do something here. FD4. Is it because of the unscaled offset thing? Literal. No. So these? Oh, is that what it is? Structures? Oh yeah, it is LDR. No. Huh? No. Huh? Which variant is that? We look at. I have to look at the decode tree for this. Where's the decode tree? Okay. OP0 will be 1 FD that loads and stores. And then this is going to be F. OP1 is going to be 1. OP2 is going to be 1 something. V is 1 size is whatever. Oh, that one, unsigned offset. Okay, so we don't care about that because that's just the offset stuff. I do care about pre-index and post-index though. So, is that the same M9 as usual for everything? Yeah. Pre-post index. Yeah, it's the same thing here. So it's basically the same thing. So let's do it like that. So let's not check that and then just do the RN decode OK. So I think those are the same as far as we're concerned. Pre-index, post-index, and then that one is unsigned offset. But these do need to be checked, those 2 bits, so they do kind of need to be separate. Yeah, okay, so 3... Well, let's only do the ones that we care about. Let's only do unsigned offset for now. They're not doing post-index, so... That would make it 3F... C. But I care about OPC being 0, 1, so actually 3F... yeah, 3FC equals... 3D 4. Yes, 3D 4, and then that's nothing. And then that's basically LDR. Immediate. NFP. Signed offset. And that's basically like that. And then it's not XRT. It would be it's probably just gonna be an array in this case, so it'll just be SIMD RT equals star val. That'll do it. And let's do the 128-bit variant 2 while we're at it. Which in this case is size 0. That's still 3. And then OPC is 11, so that's a 1, 1 there. Oh, wait, hold on. Yeah, E4, it'll be... Actually, that's not C. That's... Sorry, unsigned is... Yeah, C. OPC 1, 1, yes. So it'll be C. And decode OK, it's SIMD state. Put SIMD state, and basically this will do... This would be basically like this. So in this case, I'm just going to do... I think that should work for that one. Not. Okay. Let's see if that works. Okay, another SIMD thing. I hope we don't get too many of these. Oh, that's annoying. It's one of those vector loads. Ew. Ah. What is that address anyway? Where are we? X8. Ah. Damn it. I messed up. Let's still do this, so. Oh, I can't do HV anymore, though. Damn it. I can just run it again. What's this? 2.1.20. Actually, you know what? I'm going to change the load not emulated thing. I want to emulate load. Actually, this bail thing can just go return false. Makes more sense, to be honest. And the same thing here. And then I can print the address here. It's just more useful. Image store. IPA. Okay. This makes my life easier. Then just do it like this. P Manager, really? They're using SIMD in P Manager? Of all things? Okay, what about LD1? But then that one has multiple different... Okay, fine. So I guess this is basically the same thing except a single structure, right? So... So this will basically be Q. I'm going to use a structure for this. Actually, What was it? S? Up here. Yeah, SDQ. So this is D. S for H 8 B 16. And then here is actually D. Yeah. Okay, and then LD1, single dimension, one and one okay. That's a weird encoding. What's Q? Okay, it's 128 for that, yeah. Q is the index? This is pretty... like, the size isn't... yeah, this is kind of... it's kind of incomprehensible to get get them all separately. So I'm just going to use this for now and see what we have. Let's see. According to this is V1D 1. So that's the one from V1. So the registers, so it's not there. These 2 bits are also the registers, so that would be 4. If everything else is basically fixed, so the only question is the no offset. I think I can just ignore the top bits no offset post index. No, I also need the write back. I'm not going to do those. These are not indexed. Okay, so no offset. Sorry, write back is what I care about. These are not written back, are they? Oh, these are always write back. Okay, yes, so no offset. So in that case, we have this. Yeah, 4. So Q. Ah, here we go. The element is Q. Why is it done like this? This is so... okay. QSI, size on QSQ. And then the size is where? Oh, I see. So if size is... okay, I see. I think I kind of see what they did there. No offset, opcode is 000. 1010. No, well, that's still annoying to decode. Okay, I'm just gonna do a single one. What did they use? D. So let's only do the indexes variables. So D is 64-bit variant. And Q is the only thing that matters there. So basically it'll be B, F, 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 and then it's 3, sorry, C. Okay. I think this should do it. Did they do that anywhere else? Somebody here. Huh? Oh. Wait, 4? Oh yeah. That 4 is yeah, Okay. Right here. What? It's rebooting, right? Yeah. Whoa. Null pointer deref? Fun. Oh, sorry. No, that should be fine. Okay, hold on. Put SIMD state? No, val? Val is null. Oh, yeah, I forgot that. And also, this is wrong. Good thing to remember. Okay, this is another SIMD load. Apple pass-through ppm. Whatever that is. LDR S1, okay. It's because it's the offset version, which I'm not doing yet. So register. What was that LDR? Yeah, these probably. Yeah, these post-index and pre-index. So it'll be 3C, and then OPC should be 4 for that. Yeah. And then I do care about some of the other bits. Only that one, only the 4. It's the same as that's the same decode as here, so yeah. And that does need to be 1. It is 3FD. No, 3F E, sorry. I think it's the same, yeah, 3F A. 3F4? Oh, sorry, yeah, 3FE 400. Yeah, yeah. Yeah, it's the same, okay. So post index. And it's going to be the same plus the usual thing. Yeah. And the 128-bit version is going to be FF, and this becomes a yeah, that, and then OPC is 11, so yeah, C. I should just unify these, to be honest, because it's just that 1-bit difference. So let's do it like I don't know, there's more bits I need to match though, so yeah. Okay, so channel do okay, and then this is just this version with width 4. Hopefully that'll work. It does work. Oh, what just happened here? Panic! That panicked really quickly. How? Huh? Indeed, that faulted. I think this is an issue with that. This looks like one of those random things where sometimes the offset for the ASLR is different, and well, yeah, that's like 1E0 though. Null pointer. That's weird. That is the offset. I'm not sure what happened there. Oh wait, no, this is different. Right. This is the debugger failing, but that's not the. Okay, no. So that this is bullshit. But this is correct. And then I need to know what this is. Uh. hmm. Let's just TP either again. Probably X1. Yeah, X1 is just null. That is one too. But that failed in get sock base fizz. I think it's the same thing that happened that time. That like the boot args thing. I'm not sure what happened. I've seen this happen before, like rarely, but I don't know. I'm just gonna try again because it seems pretty random. It's only happened like once in many times from the hypervisor so far, so. Okay, getting somewhere. Aha, cool. That wasn't too bad. So it dies in a PCIe, and I've seen this happen. If I look at the yeah, F8AC, and if I do this F8AC, that's a story. Oh, a breadcrumb store. No. What? Oh, that is weird. So it returned. But hold on, but I think I know what happened here. It's a write. Yeah. And the memory barrier, right? Yeah. So this is speculation. It's doing a write to this PCIe register. It's hanging on the write, but because the CPU is happy to speculate, it's not really speculating. It's just like executing out of order instructions after the write. It doesn't wait for the write to continue until it gets to this DMB, and then it decides that it wants to wait for that to complete or something. Even though it probably did more writes before, like 5. It did a write. Wait, actually, what happened there? Actually, what happened there? One, 2W345 star. 1, 2W345. Yeah. Okay, and then 5 is correct. Yeah. Yeah. So basically, it. Before 5, then 5 goes to. Yeah, exactly. So it did the write, and then it did the breadcrumb write, and then that barrier caused it to hang. So that makes sense. Which means this is a PCIe. Something's wrong with a PCIe basically, and I don't know what it is. I'm pretty sure if I try to write to this. Actually, why is this not showing the sizes? I should show the sizes on this. Hold on. And then we evt.flags. Does that work? How do I do right side padding? Like that. But I kind of want to pad the... well, that's fine. We're going to have a space there if there's... No, it can never be a space there because it'll be obvious. Yeah. Okay, that's that. And let me try doing that again. So I know what width it is. I need the... No, it's fine. Actually, put this here because... Oh, and the width is actually... sorry. That's why I want to do that. Yeah, so you can see there's like a Cindy thing there. And then it is actually 32 bits. And yeah, this is going to hang. As expected. Yeah, so what Mark was saying right now is actually exactly what I was going to do. That it's possible the PCI initialization in Mini is confusing. Oh, but this is going to be annoying now because I have this burned in. Wait, no, that doesn't make sense. Because this works fine without the hypervisor, remember? Chain loading works, right? Obviously, if chain loading works, then it can't be that. But maybe it doesn't? Does my burned-in Mini have the PCIe thing? Maybe it doesn't. I think it doesn't, actually, yeah. Okay, let's try that without that, and... Okay, it is that, yeah, obviously. Yeah. So indeed, now I'm kind of curious, what does that break? So PCIe... So what failed earlier was a PCI 7, whatever that is. Yeah, so I don't expect the clocks enable to break things. But maybe I can just reset the PHY. Okay, I'm just going to try this with chain loading because it's a bit easier and doesn't quite take as long. So basically, it'll be a reboot, chain load, basically that. So if I do it like now, it'll fail. Wait, what? No, that's correct. Yeah. So that does that. And what if I just return like here? So I know what I have to undo. Actually, I'm just going to try undoing everything this does in sort of the obvious way, setting the resets. I think we can make these static here. Let's just... shut down, was it? And just as a test, I'm going to put it here. Um, that doesn't use this. It no, just edit the path. We can actually just get the port base. I think that's the only thing we get. Yeah. So how many ports? 3 ports. And then basically set the reset. And then the app clock. Config base. You don't care about that, do we? No. And then I don't know about that, but let's try with just the resets. Okay. It should be static, yes. Let's see what happens there. Yeah, I thought of just doing the PCI need only when booting a kernel. But I'm kind of curious as to whether I can fix it. That seems to work. So, whatever. I'm fine with that. Okay, PCI init, and put that there, and then I like my inline things. If initialized, and then in hypervisor, that's probably where I want to do it, in HV init or something. That's probably a good place to do it. Initialized. I apparently auto-completed that. What am I doing? Return. That's fine. And then here, just then. Consider that niche. Okay. That should work. Let's do that again. Oh, another thing. At least it didn't crash this time. Okay. S1. Didn't I fix that? Didn't I have that one? Well, let me commit some stuff while I'm here. So that'll go there. No. Oh, I don't need that. Get rid of that one now. Though I do want that for... I should just put that in the proxy, I guess. Because otherwise chain loading isn't going to work. Yeah, I guess practically speaking, that should really just be done when I chain load, it's still going to break it. I need a way of telling the... Yeah, I'll have to put that in the proxy later. You have the PCI thing here? No. I guess so basically it makes sense to only do the PCI need and kboot anyway. Because otherwise, yeah, I think that makes sense. Yeah, it would make sense to do it here anyway. But it's good to have an uninit function that works. So let's do it like that. And then finally, yeah, basically kboot, set chosen, set memory, so yeah, basically here anyway. Actually, that. And I need to fix that too. Yeah. But I'll be reformatting everything later when I do the things, so I might as well. Yeah. Actually, this doesn't matter. It'll be fixed. My squelch thing will take care of that anyway, as long as I don't mess up. So BC70, what is this? LDR. C70. C70, huh? 4, 5, 6, 7. Oh, no. That's D. Is it immediate pre-indexed? No. No. It should be offset. L is 1. V is 1. Signed offset is what it is. So did I just mess up the Oh, sorry. Yeah, signed offset is different. As usual. I think I included one in one of the others previously. So this should be, wait, 3C? That's not 3. Where am I? Oh, that's what it is. Oh, it's, huh? What? No, no way. BC70. EC. RS1A0? What? I'm confused. What does this decode as? Something something 1 1. And then up 3 is 1 1 blah blah blah. So these, probably that one. Up 4 is 801, so 1 0. Yeah, that. Okay, 3C70, that makes sense. SMD OPC should be 1. Yep. V is 1, and size is, well, hopefully the same anyway. Okay, that's what it is. Yeah, it's basically this, but SIMD. So 3F OPC, yeah, 3F E 0. I think this is going to decode the same, hopefully. I don't care about the scale. I care about option, which needs to be, 1 needs to be a 0, so that's where the 4 comes from. Yeah, indeed. Needs to be a 1, sorry. So that's correct, and then that's 8. Yep. So instead of 386, it's 3C6. And then it's basically the same as this. And then 128-bit version, which just sets size to 3, and then that OPC is FFE. Huh? Yeah, C instead of 6. would be E. Yep. And this is the same, and then that just does this. Okay. Let's see. Looking good. It looks like Wi-Fi is doing something. That's looking pretty good. This is looking pretty good. Ha! What now? Oh, a timeout. We're just too slow, aren't we? Am I mapping synchronous? But it's like timeout initializing the firmware on the graphics. We could cheat the time. That would be the smart thing to do. The smart thing to do would be to cheat the guest time. So where's the? I am sync tracing. Let's turn that off. And now I kind of want to do that time offset thing. So wait, this is using the V timer. So effectively, in guest exit, yeah, we can do that. We can fake the time. Actually, yeah, I'm gonna undo this. And let's set up the exception handler so that basically just HVXC entry and there. And then basically, HVGT. Let me just double check that. Chain load. Uh-huh. It's a subtract? Oh, it subtracts. Okay. Okay, so it actually subtracts. Which makes sense because we add to steal time. Actually, we do stealing time plus equals. And in principle, that should actually work. Mm-hmm. L2. Because also, if I don't do this, then if I pause with Control C or something, then the guest time would keep running, and a bunch of weird things would happen. So this makes sense to do anyway. Huh? Did it just die? Oh, I bet that's a timer that it's just slower because of my because I'm now accounting for those things. A lot of SPI junk. Oh, is that like the OS log thing? Maybe. Interesting. It's getting pretty far. Oh, come on. Though it's it's getting somewhere. HCCP now, huh? What is this? P manager again? No. Oh, PCIe something. Interesting. STUR. Okay, no, actually, hold on. Is STUR? That is a regular one. No, it is no, it is a regular structure. I should implement that. Yes, I think I have the U ones done here, but not the yeah, LDU. I have LDUR whatever, but not STUR, I guess. Yeah, so it'll be the equivalent of that. And it's gonna be, I bet, basically that or something. If we, let's see, probably that. Is it C? I don't know. Something. It'll be something like that. Let's see. STUR. And it'll be size is always 1x, apparently. Was that the case for LDR? No, the B is there, yeah. STUR, yeah, it is there. So that does have that, yeah. So one, yeah, one, So 3FE, and then there's that in there. The 00 isn't there. So C. Is it the same for the load? LDUR. Actually, let me check that. Oh, I should have those in there too. LDUR 00, 00, 00, 00, 00, 00, 00, yeah. I should be checking those here. Oh, no, I am. Okay, yeah, that's C00. It is the same. Yeah, it is the same. Cool. So it'll just be 382, 81. Was it 1? Yeah, 38 something. Yeah, 380 actually. Yeah, 380, and then all zeros. Yeah, that makes sense. Was it 382? SDR register? Yeah, it was, yeah. 382. Yeah, it was. Okay. So, STUR should be the same as this one. LDR, just decode OK, and assign it. Nothing interesting there. Okay. I'll decode OK for that. It says the Ethernet path. Interesting. Okay, let's do it again. Am I? Ah, there. Well, we know the timeout thing is fixed, so I'm going to kill that again, and turn off the sync mode because I'm just getting tired now of waiting. It's going to be a lot faster without that, so. The P manager one is so annoying. Like, what's happening is that it's polling on a register with a timeout, and the problem is that because of the emulation, it spends most of its time in the hypervisor, so it takes forever for the timeout to expire because the stolen time is much longer than the actual time it spends in the guest. So I might want to like tweak that stolen time thing to like not always account or like always tell it that a little bit more time passed or something. I think that spy stuff with the OS lock persistence I want to turn off because it's spamming way too much. Yeah. You have there. Alright. It's okay. So a lot of data board lowers there, but it's still working. Oh, service calls. Yeah, okay. So it's running user space now. It's interesting that the progress bar didn't move much. Oh, I bet I know why. I bet it's because it's accounting for time and like okay, I first of all I need to fix this because obviously service calls don't need to be printed here. Oh, it's because I'm patching the exception vectors. Let me get rid of that. I definitely don't want to do that anymore. It's gonna take ages to do anything. Exception happening. Yeah, we don't need that anymore. Okay. We got the user space. That's pretty good. Oh, what just happened there? That's weird. That looks like a bug in my capture card. What happened there? That's weird. Well, launch D is saying things. I don't know what happened with the screen though. That's weird. I think those ACTLR EL1s are gonna have to be moved into the hypervisor. Hold on, let's do that. Let me do that now, because that's probably gonna eat a lot of time because it's not even it's synchronous. It goes to Python, so MSRs, yeah. I don't know why I get ACTLR EL1 actually. Was that one EL1 too? Yeah, see, there's a lot of that, right? Yeah. What just happened here? Oh, yeah, that. It's a token? No, it needs to be ISS for us. It's kind of annoying. Can I do like... This won't compile. But can I like... I wonder if I can force that somehow to like not do that. No, I want like a pre-processing token or something. This doesn't work, does it? No. Actually, can I do it like that? No, that doesn't work. Okay. Just copy and paste. Actually, yeah. I don't know what traps this. Like, I don't know why we get that. Huh? Wait, hold on, what? Oh, it's because that's not defined. That's why. Sorry. I also need to fix that. Yeah. Tools include. Hmm. Oh, that's not even. Yeah. And it needs to be. Needs to be that. Sys. I actually should redo that one too, but. Okay. And let me also fix the IPI things. But I'm here before I forget. IPSR. Yeah, and here in this. Okay. Let me commit that one here. Not that, not that. Yeah. And let me do this too. Yes, yes. No, 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 yes, no, don't. Do a bit more of that. Okay, enough of that. Let's run it again. So slow. Oh, I bet it's waiting for like even one tick doesn't happen or something. Hold on, let me do a little quick fix since that's the what I just changed now. Lost equals to that, and then basically I want at least one tick to happen. So it'll be max. If lost is more than 2, then account for anything over 2 ticks. So every hypervisor call is at least going to be 2 ticks of the timer, which I think is reasonable. Let's just do 1. Because I bet what was happening there is that it was not counting any time because it was spending more time in the hypervisor. So almost all timer increments happened in the hypervisor, and then the guest didn't see anything. Or not. Still happening. Okay, let me do like 8. Because that way it's mostly the Python calls that... That was a bit faster, yeah. Why don't I get that corruption? That's so weird. It's like video breaks or something. It's sending a lot of crap out to whatever that is. PCIe looks like. Load image? Oh, Wi-Fi firmware. I see. Ooh, I think display initialized. This is looking pretty good. Hey! Stolen time is just added to here. Ha ha ha! Does the keyboard work? Does the keyboard work? Does USB work? Because that's an XHCI. Oh. I forget what my password is, by the way. Oh, that was it. It's thinking. Are you gonna get a desktop? Am I gonna get a desktop? Am I gonna get a desktop? We're not white at the desktop. Oh! Okay. Hold on. This needs a little celebratory patch. I have a little patch here that'll make this a lot more appropriate. Hold on. Now this is the real version. How's that? I'm just gonna let it boot. We know it's pretty slow. I hope it actually is booting. Oh, no, actually it's broken. Hold on. Let's try again. I think that was just a random fail. Yeah, I think that was just a random fail. Oh, there we go. No, I think there's some issue with my memory mappings, and depending on where in memory, like mini is randomized, right? And depending on where memory is loaded, there are some like corner cases. And yeah, I don't know why the display breaks. It's like it does something that stops the screen from working, and that noise is probably just like the frame disappearing midway through or something. So that's kind of weird. So yeah, I guess the frame buffer breaks at some point. Yeah, I might look into that a bit later. But we know it keeps working, so. Is this working? Wi-Fi firmware. I was kind of expecting it to be like this. Someone mentioned I was so sudden, the change from like chipping away to working hypervisor. The thing is, like, almost everything the kernel is going to do that is relevant to a hypervisor, it's going to do it early on, right? And so once the last, dumb thing that was missing is fixed, it goes from, dying very early to everything works. It's not actually round tripping to Python for almost anything right now in principle, but it's logging everything, right? So these register logs are why it's slow. But I can control which ranges of registers I'm logging, right? Like right now I'm logging everything on purpose. But you'll see I can turn this all off, no problem, and it should be very fast. Like literally right now I'm logging every single register right to the hardware into Python. Considering that, it's not actually that slow. Unfortunately, the logo does revert when it initializes the display. There you go. If I type correctly. It is responsive on the keyboard though, so it's not like it's super laggy. I'm actually considering using the miracles register as a hypercall. Not like basically to enable and disable specific kinds of logging. This isn't bad. I mean, obviously it's a little bit laggy, but it's not terrible. I mean, you can see it going. Let's see how long it takes for Safari to load. I would tweet from this, but I don't really feel like typing my password in here, and I don't know it by heart. It's in my password manager, so. Oh yeah, a menu bar. Where's the menu bar? Oh, I think I know what. Oh yeah, where is the menu bar? Is it still loading? It might just still be loading. Or something like that. Oh, it is there, okay. I think it was still loading. Yes, the next step is to use the hypervisor to develop a graphics driver and other drivers. I might tick off some smaller things like I2C first. It says it's connecting to Wi-Fi, but it should have Ethernet, so it shouldn't need Wi-Fi. Remember, this is like it's logging everything. Okay. But you'll see, I'm gonna, once this page loads, I'm going to shut down and turn off the logging, and you'll see how it's much snappier. I disabled hard. Oh yeah, I'm disabling the second Type-C port. I don't know if that works. I need to try with that enabled and see if it doesn't break me. But I left almost everything else enabled. So like, if you look here right now, yeah, this is all the USB stuff, and then just the extra CPUs. So the only hardware that is not necessary to disable right now is the second Type-C port. I should try with that enabled, see if it doesn't break me. Is it actually, like... Wait, is it trying to connect to my Wi-Fi or what? I mean, it's still, like, printing, logs and stuff, so... There you go. Yeah, it should just kill Wi-Fi. And make sure my Ethernet is working. It should be wired Ethernet. Assertion timer failed. Not sure if that's expected. I think it's just slow. I mean, it's just taking forever, but... Also, pmanager is sync, I think, and that's part of the problem. I had that in like that so that, yeah, and I don't need that. Okay, I'm getting kind of tired of waiting for this, so I'm going to change it to... Actually, let's see how much stuff is in there. Ask AIC, yeah, AIC is not interesting, as we know. So that definitely should go away. This is AIC0, isn't it? Yeah. So... Yeah, I mean, it's still doing things. obviously. Like, it's shutting down the Wi-Fi and stuff now. But most of it is graphics, actually. Yeah, a lot of pmanager. So I should probably kill error handler and pmanager. What is error handler? ADT. It's just under there, isn't it? Yeah. Is this spy 1 or spy? It's just spy 1. Oh, it got there. It got to Ethernet says connected. Okay, so it is actually alive. And it's probably checking for system updates. I think I saw that, which is also not going to help. Safari definitely seems busy. And let's do pmanager 2. Yeah. AOP SPMI 1, whatever that is, also doesn't look terribly interesting. Okay, so instead of doing it like this, I'm going to do it the other way around. Let's do the ones I don't log. Actually, let's do it like let's do it like this. This makes sense. That way I can have like a default at the top and a default at the top, and then specific things I want to log. So like graphics, for example, that's so this is actually the subcontroller for the graphics. Which seems to be pretty noisy, but I want SGX in there for sure. And then, what else is any other interesting noisy stuff in there I want to get rid of? And yeah, all the unknown stuff is going to go away. And then, yeah, so this makes sense. Like kill or handler AC, SPI1 pmanager, and then graphics asks SGX to true. What is that? 2351, yes, spy, right? So that should be fine. And then the system 23D12 is what exactly? Is that nowhere there? No, it's not decoding the reg on that properly, or what? Oh, yeah. So uppercase, yeah, 3D12. 12C. Oh, that's it. That's what? I think it's just pmanager, yeah. And then the UART, this is UART2, isn't it? 352, yeah. And then the other one, 5022. 50. Huh? 502. DRD. What? Oh, this is sorry, post cyber. 0000502 22. Yeah, isn't that one? Yeah, USB DRD1. It should be Mac software, otherwise map hardware. And then I'm going to default to map everything in hardware mode. And then finally, we need this for Android. It's just self-AT name, yeah. Or path. Hey, that did eventually load. So yes, it works. Let's see if I can actually do like a system shutdown. Wonder how long that's gonna take. It seems faster now, actually. I bet it was doing something like that. It was still like initializing things in the background. And oh, interesting. Another store, but only in the shutdown path. But that's fine. We can fix this without killing it. I can just do that. One more, and that should be enough. And I'm going to copy and paste this for later because I'm going to want to fix that. Just map it and continue. See, no problem. Or yes, no problem. Cool. Oh, and that was probably like right at the end, it sounds like, because I feel like I just stopped. And those hit writes smell like... Oh, it panicked. Okay. What did it panic about? Oh, monotonic, hardware ignored enable. Ah, okay, that has something to do with the timer, yeah. Interesting. Interesting. Okay, let's just kill that. And I have the source code for that, so might as well try to fix it. Oh, PMCR0. Because... Interesting. Oh, I know why that happened. No, I don't. And it fixed the N. Is it because of these things here? No, it shouldn't. Oh, it might be because like a guest can't do that. Because it expects to emulate them or something. That could well be it. But like if the host doesn't... Oh, is that it? MT-CPU PMI. Oh, that's on the PMI path. And then it does it on something. Yeah, I don't know why that's weird, but okay. Anyway, so hopefully this runs a lot faster now. Well, I'll probably mess up the... Yeah, I expected that. For adder reg in reg... oh yeah, it's not like that. The way that's done is... For reg... And then I think it starts size or something, what I use for that. And ADT... sorry, in this ADT. Or is it just 2 tuple? No. Reg goes with bus address... Sorry, address size, yeah. Oh yeah, and also this needs to be padded. So actually, no. It should be... I think that should work. Yeah. Oh yeah, that. Good point. Oh yeah, and I should try removing the. Oh, there we go. That seems to work. Oh, and that's not an F string apparently. By the way, the one that messed up is P manager. No, that is aligned. Why? Oh no, it's aligned. So I already aligned it now. This one? Oh yeah, this one. Sorry. Yeah, good point. But also I'm going to do the RMIO thing. I know there's a Git thing here. The one I needed. This I want to undo. Oh, this one. Sorry. I think it's this one. Yeah. IDX. Yeah. It's just like that. And that way we'll see if the other USB port works. Though I can't actually connect to it because it's blocked by my like daughter board for the other one. But at least I want to see if it doesn't kill me by having that enabled. Hold on, I'm getting like... Oh, what just happened here? Why am I... Oh, that's the P manager stuff. Okay, so that's working, but... Why am I not getting it? Oh, because I'm only logging things that haven't initialized yet. Once the graphics come up, it should start logging. Yeah, see, so I'm like already at launch D. I hope. Unless I messed that up. SGX traffic ask, it should. Also, by the way, remember that this is a development kernel, so it has a lot of like debugging things burned in. 671, a comma? Yeah, that's correct. Not actually logging anything though. I think the graphics aren't just up yet. Does that mean that it's going to do the Apple look? No, it's probably going to start initializing graphics now. So just did the output controller. Did I fix the map software to map hardware thing before I started running this? I think I did. Ooh. Oh, that's an... Oh, PMC. Yeah, okay. You did a PMC. That's fine. I just ignore those. But I'm not sure if the graphics is doing something or... Doesn't look like it. No, I think it's something's broken here. Not sure though. Should be tracing graphics and SGX. It's possible it's still not initialized yet. Unless one of those overrode the other one. No, but those are last. That should be fine. No, still nothing though. Okay, so something's broken, but at least it did boot. Let me kill that. Actually, no, I can... Wait, why did Control-C not work? Control-C should work. Huh. Well, that might be my console being dumb or something. Oh, no! I know... I think USB died. Either that or my periodic timer is broken. But interestingly, it booted. That's weird. Also, PMC interrupt. Why? Something strange happened here, basically. It's still running, though. I mean, when I don't log anything, obviously that can happen, but... Yeah, interesting. I think it's not logging anything, and so it would still run. But no, the timer should work, though. Okay, so hold on. Let me undo that. And kill that, too. Does Control-C work? No, something is weird. Hold on. Is it just my terminal? Okay, that does work. I think it was just my shell being stupid. Oh, but then it stops working. Is it a timer thing? Does it kill my timer? Interesting. No, but it can, because then the watchdog would bark. And it's not. Is it just USB that died? Well, it worked a second ago. I mean, yeah, it's not receiving anything. Oh, I know why. Duh. Yeah, if it doesn't send anything, it doesn't pull. Obviously. No, it does. No, wait, do I do handle events in... Oh, I don't know. I just check for... That's why. That's why. Because in HV exception, I do... In FIQ, I do the exit, and then in HV here, I just do... Can read, yeah. In exception exit, I check for can read, and can read just does... Can read just does for USB. That only checks the ring buffer. Yes, I need to handle events in the timer, and honestly, this should also be in the timer path. There's no real reason to do it here. Yeah, basically here in tick. And then an IODev handle events thing. Yeah, that's why. And then the question is, why isn't it logging the things I want to log? Oh, I know why. Because these are not resolved properly. Yeah, sorry, I'm doing this wrong. It's not reg dot. It's what I need is this get reg, and it returns out. Yeah, okay. Index enumerate self reg. Sorry, range len. Yeah. I guess that needs to be passed there. Okay. Let's try that again. Actually, let me commit some stuff. Yeah, we can do that. Nothing here, but let's do the tick stuff. Split that, yes, yes, no, yes, nothing there. No. Let's do the logo thing. That's a formatting thing. That's fine. That will be fixed by the thing. Okay, and then finally, let's see. Cool. And when we forget, we do that. Yep. Okay. Finally. Is this going to work? Let's show that there. Aha, okay. Now we have PMP. That's probably some overlap with something. Oh, I bet it's the ASC thing. Like maybe the ASCs have overlapping registers or something. It's doing things though. Yep. I don't want to figure out why the frame buffer dies. It just annoys me. Hey, it's doing stuff. And yeah, but it's doing PMP things now every now and then. And by the way, breakpoints work now. And I can get a backtrace. That PMP thing is pretty noisy. Oh, hey, there we go. There, now the GPU is happening. Yeah, there you go. And I bet it's a lot snappier now. I'm still logging all the graphics calls, so it's still going to be a bit dodgy, but also remember this is running on a single efficiency core, so it's supposed to be slow. Oh, it's already booting Safari. Honestly, I could just move the hypervisor to one of the performance cores and probably improve a lot. But still, okay, this wasn't as bad as before. I want to get rid of this PMP stuff. Hold on, let me fix that. Breakpoints. Map hardware. Give me hardware on that. Continue. And now it's gone. Isn't it cool that I like, you know, breakpoint it and get a backtrace? In this case, probably user space something, or you know, something I don't know about, and just const. Sorry, keep going. And why is the Wi-Fi? Oh, it probably didn't save the setting when I shut down or something because it died last time. Turn Wi-Fi off. It's loading. It's loading. Haha! So this is actually usable, especially because I can turn the tracing on and off dynamically, right? So like right now, it's tracing all the graphics and everything, but I could just... do I trace something? No. It is, yeah, it is getting big bursts. And you can see how it's... If you look at the scroll bar here, it probably is related to the drawing, right? Like if I drag a window or something, I bet it will... Yeah, see? Because I'm logging the graphics, right? So screen redraws cause it to send lots of MIO. Hold on. I don't know if you can tell here, but it's hard to see because of all the... I should add a timestamp thing in the corner here or something, but you get the idea. Like... Cool. And yeah, this isn't bad. I'm not going to dare actually try to run a macOS update with the hypervisor. That'd be a terrible idea. But I bet it's going to check at least and tell me, you want to install 11.4? And now that the little spinner is going, it's doing a lot more. What it's doing. Is it even, is it printing stuff? I don't know. SCP commands and stuff. That is slow. Whatever the Apple... Oh, there you go. 11.4. No, I am not going to update now. Are we doing the tweet? I guess I can do the tweet, but you're going to have to give me a second because I need to get my password in. Also, I have to test. I need my YubiKey for this, so that means testing the. Oh, USB. I'm already using it for the keyboard anyway. But can I fit this in the port? Do I want to touch the port now? I can just use the TOTP mode though. Nah, I'm too scared to try to plug something into the back, and I'll use TOTP mode. I think I remember that. So would it tell me like it's an M1 with 1 core or something like that? Startup disk Linux. Doesn't show storage, or is it thinking? It's probably thinking. Does this show the CPUs? And I already forgot the password. Give me a second. That's what I get for distracting myself. Okay. No. The keyboard is a little bit slow on Twitter. Who knows what Twitter is doing? No. Wait, did I not have authentication on this? Maybe I don't have 2FA on this yet. I guess I don't. I should do that. And finally... Oh, it does say 8 cores. That is a lie. The ADT does not have 8 cores. So they probably just have like a mapping table for M1 or something. I don't know how to... Like, is there like a list cores thing in macOS that actually shows you? No, probably not. Because I remember you couldn't even get the affinity set up properly, so... But maybe showing that like there's no USB controllers will say something. Nah. Or is it just thinking? I don't know what it's doing, to be honest. I could change the ADT, actually. We could do that. Hold on, I have an idea. Because the model is there. This control hardware and CPU. That's the terminal. Come on, Wi-Fi, go away. It's turned off. Why is it still doing that? Spotlight's gonna be slow, isn't it? Maybe it's even disabled. Let's not use that. Oh, that was slow. Whatever that was doing. But I'm gonna no. Let's do it that way. Model name Mac Mini. I think I can fix that. The video's not too bad actually. If you look at it, it's playing pretty smooth. Yeah. Hold on. Let's change the ADT and reboot. I can. Oh, actually, does this get used? M1 2020? Probably that, yeah. Product description and product name on product. Yeah. Which is in the root. So, in principle, if I do... And then set up ADT, I will just do self dot ADT product dot product name and then the other one is product description. I'm gonna try shutting down again and see what happens. See if this time it dies or not. Yeah, find reopen Windows. Ooh. Yeah, so it dies on it does a PMC interrupt and then something weird happens there. Same thing as before? Yeah, hardware ignored enable. 30033403. What's the code for that? 1 second, let me just check that real quick. Oh, yeah, PMI init. Yeah, okay, that's why, because I disabled the interrupts. Yeah, that makes sense. So it's just... in that case, what I want to do is just ACK it. I really want to just re-inject it into the guest, but I don't have a good way of proxying that, I guess. Because I can't really mask it is the issue. I can hook these registers, though. And could virtualize it. But it's only doing the mask, so as long as I clear IACT, it'll probably not hate me. But then it's gonna make noise. Whatever, I don't care. I'll deal with that later. So, let's go. Ah, see, so this time it just disappeared, which is actually what I kind of expected. So I don't know. It's going, right? Yeah. There we go. Churning. Oh yeah, I should get rid of that PMP thing. It just seems like the network takes time to come up, honestly. Twitter's loading. Come on, about this Mac takes a while. Who knows what it's doing? Oh, it's reverting to snapshot? Oh, I bet, like, the update thing is also doing some crazy stuff with APFS. Or something. Or maybe just stop logging, I don't know. Let's open Activity Monitor. Should put that in my taskbar too. Ah, damn, it didn't work. Uh, is it because did it actually work? Hold on, I can do I'm too lazy to use the term from there, but I can what was I saying? Is it 2244? Oh, SSH is not running. Ah, yeah, because the system update probably SSHD isn't running. That's annoying. Actually, I can check the ADT from here. Let's make sure if it's working. Yeah, it definitely worked on setting those. So, sock name Apple M1 Mac Mini. Maybe this will work. Maybe if I set sock name, maybe it'll listen to that. So the Finder thing, applications. Let's get these down here. No, not there. Ah, not where I want to put it. This is, by the way, a track point, and I'm trying to operate it with one hand. Oh, interesting. That showed up as a shortcut. The terminal. No. It's there. And get rid of a bunch of nonsense we don't need. That's more like it. And get rid of that. I can't modify the ADT live. But I want to check what it thinks of the ADT. Wait, does Activity Monitor even show the number of CPUs you have? Is this supposed to be separate CPUs normally, or it might just not do it? Also, I want to. Why is Wi-Fi still blinking? I don't know what that's about. An activity monitor. Oh, this? Oh, that. Yeah, so then it is one CPU. Double clicking here doesn't do anything. Maybe if it's one you want, it doesn't split it. So what's blinking now? Can I make it like turn off at startup somehow? Whatever. That's what I mean. Yeah, Core 1 efficiency. There you go. That's what you were saying. So kill that. There you go. What? They just time out on deleting this shortcut? Really? Now it worked. And then also, let me turn on SSH while I'm here. Was it under network or services or what? I think it was network. Or not. I forget where that was. Oh, the mouse stopped responding. Did something just happen? Oh, huh? Oh, the PMC interrupt fired. Did that break everything? Oh, it just panicked, I think. Hardware time since the screen time. Yeah, well. Same issue. Okay, so it really doesn't like that. Okay. Let's see if the hack to show that worked. I'll probably end up virtualizing the PMCs. There's a trap bit for that, and I can just make it all virtual and like make it ignore them or something, or mask it behind the scenes, and then might even be a boot art to disable it. Oh, missing space there, was it? Oh yeah, that. Good point. And also, this didn't work because I messed up the. Oh, product stock name. Sorry. That. Oh, yeah, that happens because I did it twice. I really need to make it support multi-CPU just so it's a lot faster. It's not that hard, just a big mutex, really. That's all I need. It actually doesn't need the lock for everything. Like the MMI emulation code would be fine without the lock, pretty much. Unless I start mutating page tables, but I don't normally do that. So it would be more like if it calls into Python, then that should definitely happen on one core at once. And also the polling, the tick stuff should only happen on one core. And that's mostly it. Where's the sharing thing? Here. Kill that. Kill that. May or may not need a terminal. And by the way, I think the reason why the CPU usage is shown as low is because my hypervisor stalling time is kind of cheating, right? And so it thinks it's idle more than it actually is. Not network sharing. Yeah, that. It's actually going to work. I don't even know if the network is up yet. It is. Yeah, why is it doing like APFS snapshots, or what on earth is it doing? That's the thing. Is it does something with an update or what? I don't know. I think it might be because it's trying to like download a software update or something. I think that worked. Yes. Awesome. So I don't need the terminal. And now we wait for Twitter to load. I don't care about the serial number. I think it's been like on my ADT on streams a bunch of times already. I don't care. SSH is definitely slow. This is yeah, MMO trace is working. Oh yeah, the PMP thing. I forgot about that. Should be a bit faster now, unless I broke it, which I might have. No, it's still working. Cool. Aha. Does this resize? It does. Okay, I think it's time for the screenshot. Okay, close enough. And now we wait for Twitter to work. What's the macOS screenshot key again for full screen? Like a Command Shift 4 or what was it? Run safe something. Oh, did I click this? Oh, now it works. That works, right? Final check before I hit tweet. Okay, here we go. 3, 2, 1, go. That was fast. I thought of the recursive thing, but then people would say it's fake. Okay, well, I think that wraps up today. Thank you for coming. It was a long road getting here, and obviously all the fun stuff starts now. So, yep. Actually, before I go, I'm going to do one more thing. Let's take off all the tracing and see how slow it is. Oh, did it just fail? I think it just crashed again. Well, that was just in time then. Okay, I can fix the PMC thing. I'll virtualize it or something, whatever. I'll figure something out. But yeah, see you all next time. And it gets interesting from here on. Bye.